you cannot think of anything in engineering which is done by a single engineer. We are by definition a collaborative cohort. We have to work together. And all the big challenges of the 21st century are really, mechanical engineering, electrical, electronic engineering, chemical engineering, material science, all together.
Hello, I'm Sue Nelson and welcome to the Create the Future podcast, brought to you by the Queen Elizabeth Prize for Engineering, celebrating engineering visionaries and inspiring creative minds. Mischa Dohler could easily be called a polymath. He's an engineer, a composer, speaks 6 languages, plays the piano, has 5 albums on Spotify, and is the Chair Professor of Wireless Communications at King's College London's Centre for Telecommunications Research in their Department of Engineering, the first to build a fully functioning 5G system for the UK. He's also worked for France Telecom, co-founded World Sensing, Europe's largest Internet of Things company, is editor-in-chief of 2 journals, and is on the advisory board of the UK's communications regulator Ofcom. Mischa has a degree in telecommunications from Dresden University of Technology and from King's College London, both a master's and a PhD in telecommunications. So I thought it best to start with 5G and get him to explain what the key difference is between this and 4G, which for a lot of people is already pretty good.
Yeah, people always wonder, why do we need a new generation? And it turns out that in telecoms, we're quite lucky, actually, and that the key performance indicators, so performance in general to the consumer, improve by 1 or 2 orders of magnitude. So let's look at the data rate. And if we look how, the data rate has improved from 3G to 4G to 5G, we see that actually, it's always been multiplied by 10. So if you do have a 5G phone with you today, you can have an average data rate of about 100 megabits per second. And on a good day or on a good night when nobody else is using the system is about 1 gigabit per second, right? And then 4G, it's a tenth of that. And the same happens with the latency. So that's something which we haven't really paid attention to in 4G, but became really important in 5G in that the delay it takes when you click on your mobile phone and load a website, that latency in 4G was about, anything between 60 and 100 milliseconds. In 5G, this is now down to 10 milliseconds and sometimes to 1 millisecond. And you may wonder, why do we need such a low latency? Well, it turns out there's some very attractive 5G applications which need exactly that.
Gosh, when you're talking about milliseconds, it blows the mind, really. But can people really tell the difference?
Consciously we cannot. Of course we cannot. We can't really measure that. But subconsciously, interestingly, we can. And as a human being, we're geared for millions of years towards a 10 millisecond interaction. It's actually exactly the time it takes for the optical signal enter my eye and then the signal being transported to my brain, being processed. So every time I get my optical visuals within 10 milliseconds, I know I am with somebody. I get this feeling of immediacy, of this, full immersion. And with that come, of course, all these emotions we get when we meet people, right? So you realize, of course, that, meeting somebody in person is very different to meeting somebody over Zoom. And that's exactly because of these 10 milliseconds. And, having 5G now around the corner allows us for the very first time in tech history to actually recreate these type of emotions when people meet whilst actually not being in the very same physical place. So yes, these 10 milliseconds or 1 millisecond really matter to humans.
It's interesting you use the word emotion there, because I've seen that you've spoken about wanting to give technology a soul.
Yeah. Yes, I just realized that we as engineers, we are really good in building boxes and writing millions of lines of codes, and often people then don't understand, why are we doing that? And you go to these tech shows, and all these boxes are being shown off. And when we started designing 5G, I realized that actually what we need to do is to really reach out to the demand side, to people who will be using that. And with 5G, I figured, we don't want to do this. So we don't want to end up in 2020 when the tech comes out, and then suddenly everybody's asking, why do we need this, right? So as early as 2014, 15, we started at King. We started to reach out, to theaters, to people, to doctors, to transport companies. Just ask them a simple question. If you had a piece of technology, it's called 5G, coming out in 2020, what would you do? And of course, everybody was rejecting me initially because they just thought it's just a piece of tech they're using every day. But over time, I was very persistent. Over time, we kind of came together, did very, very interesting co-creation workshops. And over time, we realized, my engineers realized that there's more to tech, and people using it realized, there's more than just an Ethernet cable, which happens to be invisible. So that's why I call it giving technology a soul, because when you start co-creating, a lot of really interesting things come out.
And let's go to the less emotional side of it, although I'm sure designing something like 5G is filled with emotions in terms of pride and what have you. But what did building that system actually involve?
A lot of revolution has actually happened with 5G. So probably the biggest tech revolution with 5G is really that we transited from a system which was very much hardware based and box driven to one which was completely software driven. Okay, and having a software driven system is actually really a revolution in telecoms. You using a computer every day, and that transition in the computing industry has happened a few decades back. And if you look at, I'm sitting right now in front of a Dell computer. It's been, manufactured by Dell. My operating system is Microsoft, and I'm using a Chrome browser, right? We have completely decoupled essentially hardware, middleware, and software. Now, in the telco industry, that was not the case until 5G came along. And we believe that decoupling that hardware, the middleware and the software which will run 5G really will accelerate innovation, because everybody now can essentially work at much quicker cycles. So this is really one of the very, very big revolutions which has happened in 5G. And then there are loads of smaller tech revolutions. We're using frequencies, much higher frequencies in the gigahertz range, which nobody dared to use before. We didn't even know it would work. And it turns out it does work. And we are using that today. So a lot of small components, innovations, a lot of really interesting stuff. But for me, really, the big change is that change in operating philosophy, from hardware to a fairly open, software driven, and federated telco ecosystem.
Now, I mentioned in the introduction that you play the piano, you're a composer. So it's quite interesting that your passions combined when you worked on the world's first interactive 5G music concert. Explain how that concert worked then. Where were you?
So yes, we did essentially the world's first 5G piano concert it was. And I was in Berlin. I was playing under the Brandenburger Turm, and my daughter Noah, she was in the Guildhall in London. And we thought, let's do this in the Guildhall because it is the UK's oldest entertainment venue. So the Romans brought that about 2,000 years, into the UK. And we thought, let's combine this very historic entertainment venue with this very modern technology called 5G. So my daughter was singing there. I was in Berlin. And yes, we could have done this over a Zoom or Skype call, but the latency would have been in the order of 150, 200 milliseconds. We could have also used, a very specialized cable to connect both venues and bring down the latency to something like 10 milliseconds, but it would have been very expensive. Or the novelty, the pioneering contribution of this concept was really to use what will eventually become a commodity technology called 5G. Everybody can use it. Any musicians, anybody who wants to use it, and connect themselves, within 10, 20 millisecond reach to any point in the world. And that's what we wanted to show, two continents, two countries apart, linked on a very emotional link. This is a father daughter link here. To be honest with you, so, I struggled not to cry during my actual performance because it felt like Noah was with me. Noah was standing
Oh.
beside me, with me in Berlin. So it was a wonderful moment.
And she's quite young, isn't she?
Well, we did. Yes, she's 14, and back then she was 12. But yeah, she loves singing. She brings sings in the Royal Opera House. She sang with Madonna as well when she released her new album Madame X. So she just loves to be on stage. But she was nervous. We were all nervous. We didn't even know if it would work, but it turned out to be really well. So
And what is it about the area of telecommunications that you enjoy as an engineer? Is it the coding side? Is it the technical side? Is it the combining it with the arts and music?
it comes in wave, it comes really in waves. And because we have a bit of time designing these generations, initially it is a use case exploration, which is what we did in 2015 and 14 with 5G. But then, it becomes hands-on very quickly because we need to design the architecture, meaning, we are kind of building the building blocks of the entire system, and it's extremely, extremely complicated. The fact that you can buy a phone in the UK with a SIM card in Spain, an operating system made in the US, and you are actually in South America and calling your friend in Australia, it's because we make it happen, but it's really complicated in the back. So, building the design of that is one thing. Then we need to prototype. So there needs to be a lab where we can build it. Then we start standardizing this. So we contribute to standards. Then we build policies around this to make sure there's an uptake of the technology. And then we really start, kind of embedding it into, let's say, theaters. We start using the technology. Then there's often a lot of press and media. And then we start from zero again with the next generation, right? So we go in these cycles, which is actually quite exciting.
You worked at Orange France Telecom. That was a couple of years after your PhD. What did you do in between that led up to that position as senior researcher?
Yeah, so I was actually an academic at King's. So I was a lecturer in King's College. So I finished my PhD. I got the lecturer position, and my wife got a fantastic offer in the particle accelerator in France. We lived apart for 1 year, and I said, I just don't want to do it. And I left my King's position and moved to France and got that position at France Telecom, which was really brilliant because we started to work on exciting topics, which 10 years later turned out to be a really big thing. We, for instance, co-founded the standards group on ETSI end-to-end machine-to-machine, which is underpinning now all the IoT connectivity in the world. So, back then you wouldn't know. We're doing many of these activities every day, and some of them turn really big. So that's really my big thing I did at France Telecom.
And is this sort of part and parcel of a career in engineering that you can work on specific research and some of it will go on to transform the world and others won't necessarily, have that big of an impact?
Yeah. It's exactly this, right? And that makes it also so exciting. And it's research is really about opening doors and trying to understand if there's something new, something exciting, something viable behind that door. And whilst you open it, you often open up many more doors. And so as an engineer, I think we learn really to keep things very tangible, and that's what I like about engineering. As I think if I look at my mathematics friends and physics friends, they can spend decades on string theory. It's just not possible that we spend decades on 2G or 3G because the field just really moves on very quickly. So I think that tangible aspect, building impact, usage, societal transformation is really what excites me. But there's a bit of trial and error, really, and a lot of things we did back then, haven't led to anything. But you just don't know, right? It may somebody may read about our research we did 10 years back, maybe in 20 years' time, and there's sparks a new idea. That connectivity in the research community is quite fascinating.
Was that period of time at Orange France then what sort of got you interested in becoming an entrepreneur and investing in startups and small companies yourself?
So it definitely triggered that. The inspiration, though, to do it came from my father. I have to say, my father really is a very inspirational figure. He was a professor in informatics in physics in Germany, right in Jena, in the city where I grew up. In He built at the age of 65. He solved an open problem the optics community had for 300 years, and he built a whole company empire around this on how to make aspherical lenses much cheaper, how to produce them at scale really cheaply but high quality. And it's they're now market leader. It's $100 million company. I thought, if my dad can do this at the age of 65, I should be able to do it at the age, I can't remember how old I was, maybe 30 back then. And that was really the kind of the inspiration, bring both together, right? So I had something to do, which came out of France Telecom, triggered by the actual inspiration of my dad. This is how my first company really came about.
Gosh, that's incredible. That's some inspirational figure, though, isn't it, to have a father that does
Yeah,
that, a
yeah.
parent? And I was surprised to see that as an entrepreneur advisor, a technology advisor for startups, that the House of Lords came among that.
Yeah, look, I mean, it was less about teaching them about entrepreneurship, but more about, teaching them about being more entrepreneurial. You know what I mean? So a little bit more dynamic, engaging, stakeholder engagement, tell them what are the latest technologies, what could be done, what can IoT do, what could 5G do, what are the opportunities and threats of cybersecurity. So that type of stuff. And I find it quite fascinating. In fact, I lived in 6, 7 countries, I don't know, and it's actually really the UK, House of Lords, House of Parliament, actually both sides, as well as the various ministries, DCMS and BEIS, really interested in tech, really interested in reaching out. There's a very close connection between innovators, people who really move the field, and those who write the policy. So I think that's really an amazing thing about the United Kingdom.
And this sort of communication in terms of what you do, this I've seen some of your YouTube videos. You're very enthusiastic, very effective at communications. You obviously see that part and dealing with the media as well as an important part of being an engineer.
Yes, we need more of that. We need more training of that, and I always say that. And in fact, I see this at King's as well, and that's why we implemented a totally new set of courses. And I'm teaching myself an entrepreneurship and leadership course because whilst traditionally we're very good in building and upskilling people to become the most fantastic engineers. They really know all about bits and bytes and soldering and components and building boxes, right? What we talked about before, but they're not so good in communicating this. And not even talking about the media. I'm talking about their own peers, about their boss, about the people they work with. So I think engineering really needs more of that. We need to teach more soft skills. It's not about hard skills, more soft skills, leadership, management, entrepreneurship, being entrepreneurial, what I alluded to before. And it's particularly important in engineering because you cannot think of anything in engineering which is done by a single engineer. We are, by definition, a collaborative kind of cohort. We have to work together. And all the big challenges of the 21st century are really, mechanical engineering, electrical, electronic engineering, chemical engineering, material science all together.
I'm going to refer back now to a word that you used earlier to see how important it has been in your career, even though there doesn't seem to be that much of it. And that word is rejection. You said that, you had various ideas being rejected. How important is that rejection for an engineer?
Yeah, it's rejection and failure. Okay,
Mm.
it's rejection and failure, and it is important. It makes us stronger. It's always painful, and people say you have to pass through this phase so you understand really what are the boundaries, what's the doable, where do you need to push against. But it is painful. Okay, so it's really not an easy process. And I have failed on a lot of things. I've tried a lot of things. I've tried to introduce new things, and there was either a problem I failed with funding, or I failed with kind of creating the impact I wanted to create. But it only made me understand on really how to operate, how society works. And I also started to recognize that you really need everybody. There aren't just 3 4 people really moving the field. You need everybody to move it. And that kind of allowed me also to build what I call the streamlined impact pipeline. In fact, I had explained it earlier. So you would start with an idea, you try to get funding, you would then start designing it, you start prototyping that, engage with industry, standardize it, build a policy work around this, and then bring it out, make a company around it, build a product, get media attention. So really understanding that impact pipeline, I think it has come about because I was rejected on a lot of ideas. I failed on a lot of things I would have loved to make happen. So here we are. It's just part of the process. And since we engineers do a lot of trial and error, it's just part of our portfolio.
And what about the future then? You mentioned, you've already referred to 6G. You mentioned how the Internet of Things took a lot longer than you expected to come together. Do you still see the Internet of Things and 6G as something that's going to happen fairly soon, or is it still always feeling just slightly out of reach?
Yeah, so interesting. The Internet of Things, so the ability to connect, sensors and actuators and the billions and trillions around the world, is a slow revolution happening in the back, and we can now use 4G systems, 5G systems in the future, 6G systems to connect it. The problem is not the connectivity. The problem with the IoT was always the demand side, but it's picking up now. And I always like to liken the demand side to a wine, a good bottle of wine, right? So when you want to enjoy your wine, you typically open it and then you have to wait no matter what happens. No matter how good or bad the wine is, there's nothing you can do about it. The wine takes time to really oxygenate, and so you can consume this perfect glass of wine. And the same with the demand side industry. So we produce a lot of tech, and then we just need to wait. We shouldn't lose really patience here. For the future, we work now on other things. I work on the Internet of Skills, which I believe will be the next generation internet after the Internet of Things. So the ability to connect skill sets, so you can conduct skills through the internet, without actually needing to move. We can transmit audio and video today, read emails, but I can't touch through the internet. I can't move a box. I can't repair an engine through the internet. And imagine you could do that in 5 to 6 years' time. And we needed 5G for that, and probably constituents of 6G. But we're really working on this. I always see these generations as an enabler for the bigger picture. For me, the big picture now is that Internet of Skills.
And you've already given some useful advice already. For younger people who are considering a career and perhaps haven't thought about telecommunications, what would your advice be for them?
So telecoms in the 21st century, I think it will really be a cornerstone of so many things: connectivity, digital, the fabric of society altogether. So I think it's a career really worth pursuing, but it's unfortunately not only anymore just doing, telecoms. Where I'm currently looking, I can tell you, I'm currently looking for students who are brilliant in computer science and artificial intelligence. In the future, we'll be looking for students who know about quantum and quantum programming. So therefore, if you upskill, in technologies which are emerging at the moment, such as quantum, including quantum security, the quantum networking capabilities, quantum programming, anything related to artificial intelligence, but the core domains such as convolutional neural networks, but also more advanced ones such as neuromorphic computing, or distributed artificial intelligence, as well as other domains combining, for instance, quantum and AI, as well as cybersecurity as a field in general. So these are huge enablers which allow us to build these next generation systems and really make them usable for society. So that would be my recommendation. My other one would be keep it real, try to be hands on, don't only learn from stuff, anything. I always say, for every big data, there needs to be a big action, right? So for every hour you spend behind the screen or in the classroom learning something, you should be spending an hour building it as well, right? For every hour playing a game, you should create a game. So this is really what moves us as engineers, as society. So that would be my advice to the youngsters of today.
I love the thought then of that phrase, let's upskill and keep it real. Well, Mischa Dohler, thank you very much for joining me on the Create the Future podcast.
My pleasure. Thank you.
Find out more about the Queen Elizabeth Prize for Engineering by following QE Prize on Twitter and Instagram, or visit qeprize.org. Thanks for listening, and join me again next time.